So before we get into the numerical, we know that to compute the ABCD parameters, generally what we do is we compute the parameter A and parameter C by connecting a voltage source at the input side, and we open circuit the output. So if this is the two-port network, we are going to connect a voltage source at the input and we are making the output open circuited, which means the current I2 is 0. And to find the parameter B and D, what we do is we connect the voltage source at the input side, that is V1, and we are going to short the output. So when output is shorted, it is equivalent to saying the output voltage V2 is equal to 0. So this is the standard way of computing the parameters A and C and the parameters B and D. But in some of the numericals, they can specify as to which parameter or which port is open circuited or which port is short circuited. So accordingly, we need to make modifications in the circuit so that we can compute the parameters AC and BD. So here is a question which says you need to use the following direct current measurements on a two-port network and calculate the transmission parameters for the network. So if you observe in the parameters that are specified, you can see that they have specified port 1 to be open and port 1 to be short circuited. So here in this case, they have used port 1 as an open circuit and port 1 as a short circuit. They have specified that port 1 is open, right? So let me consider the circuit with port 1 open. So this is the two-port network. This side would be the port 1 and this side would be the port 2. So if the port 1 is open, it's equivalent to saying that it is open circuited, which means the current I1 is equal to 0, and you need to connect a voltage source V2 at the output side. Then you have port 1 short circuited, which means if you consider the two-port network with port 1 short circuited, then V1 will be equal to 0 and output has to be connected with the voltage source V2. Now I need to use the parameters with port 1 open and with port 1 short circuited. So let me consider the standard form of the equation. I have V1 to be equal to A V2 minus B I2 and I1 to be equal to C V2 minus D I2. Let me name this as equation number 1 and this as equation number 2. Now let me consider the first case with port 1 open. So if I consider the equation 1 with I1 equal to 0, what will be the equation? It will be V1 equal to A V2 minus B I2. Substitute the parameters or the values of V1, V2 and I2. So I have I1 to be equal to 0, V1 is equal to 1 into 10 to the power minus 3 V2 is 10 volt and I2 is 200 micro. So let me name this as equation number 3. Now if V1 is equal to 0, you have to consider the parameters of the short circuit. So you have equation as V1 equal to AV2 minus BI2, right? So V1 is equal to 0 means you have to consider 0 here. A into V2. V2 is 5 for the short circuit and I2 is 80 micro. Name this as equation number 4. So now this equation number 4 gives you a relationship between A and B. Substitute this in equation number 3 and find out the value of A and B. So this can be written as A equal to B into 80 micro divided by 5. So substitute this value of A in equation 3. Substituting B is equal to minus 25 ohms and A is equal to, now similarly use the equation 2 and compute. So using the equation 2, you have, if you look at the equation 2 is I1 is equal to CV2 minus DI2. So I1 is equal to CV2 minus DI2. So substitute when I1 is equal to 0. So what happens here? I1 is equal to 0 means it will be 0 C into, so you have to use the parameters that are given for port 1 open. So substitute for V2 there. So that is 10 minus D into, what is the value of I2? 200 micro. So here you will get the relation between C and D, that is equal to 20 micro D. Let me name this as equation number 5. Then when P1 is equal to 0, use the same equation, but now you have to use the parameters that are given when port 1 is short circuited. So you have minus 0.5 micro, that is equal to C into 5 minus D into 80. You know the relationship between C and D. Substitute and compute the value of D and then compute the value of C. Okay.